to Chapter 2 review. We're just about ready to finish up Chapter 2, but now we need to just refresh, make sure we are ready for our test and ready to do the review on our own. So, we're just going to go through a bunch of different questions today, and yeah. So here we first have a pie chart. And if you look at it, it's a favorite food of 200 people surveyed. 53% of people like tacos, 38% like pizza, and 9% like tofu. So the first question to ask is, how big is the central angle of the tofu section? Now, we can find that number pretty easily because they give us the amount of people that were asked and because they give us the percentage. So remember we talked about a percent. 9% is really the same as the decimal 0.09. Alright, and how many degrees are in a circle? There's 360 degrees in a circle, and so we want to know what 0.09 of that, or 9% of that 360 degrees are. So we take 360 times 0.09 times 0.09, and that's going to give us our central angle. And so if we do that in your calculator right now, we get that the central angle is 32.4 degrees. And so that is the answer to that question. The next question, it says, how many of the people prefer tacos, pizza, or tofu? So because they gave us the number of people that were actually surveyed, we can find this a little bit easier. We know that 53% of the people like tacos, so we can actually turn that 53% into a decimal, so it'll be 0.53, and if we multiply that by the number of people, 200, we will find out exactly how many people like tacos. And we can do that for each one. And so for tacos, we have 106 people. I'm just going to write 106 tacos. For pizza, we take that percent 0.38 times 200. We have 76 pizza. We take tofu, we turn that one into a decimal as well, 0.09 times 200, and we get 18 tofu. And that's all there is to that. So the next question they ask is, when should you use a pie chart versus a bar graph? And so this one makes you have to pause and think a little bit. So if we think about a pie chart, how many variables are in a pie chart? Well, there's one. We're comparing the parts of a whole. And in a bar graph, we have a bunch of different variables that we're measuring or comparing. So we use a pie chart when we only have one variable. Only one variable, and we want to compare the parts of a whole. So when do we want to use a dot plot versus a pie chart? Sorry about that. We want to use a dot plot when we're dealing with a quantitative variable. So we use a dot plot over a pie chart. And when you use a stem and leaf plot versus a dot plot? Well, a stem and leaf plot you want to use when you can split your number into two parts. Split into two parts. And we'll actually do some examples that kind of show us when a stem and leaf plot is a better option over a dot plot today. And once you use a histogram versus a stem and leaf plot, well, histograms are talking about intervals. So when you have to deal with intervals, that's when you want to use a histogram. Alright, so here we have, when we find the center of the data, we've been finding V. Well, what is the middle of the data? That's what we call the median. Remember that? Doppler measures the central tendency. It represents the middle of the data, the exact middle. And what it means is that 50% of the data is larger than it and 50% of the data is smaller than it. So if you're dealing with 35 numbers, what number would be the center of those numbers would be where? Well, if you think about it, with 35 can be divided up into 17, 17, and 1. That 1 in the middle would be it, so that would be the 18th number. Alright, but if you're dealing with 40 numbers, you're going to have 20, and you're going to have 20. So if you think about it another way, you're going to have 19, you're going to have 1 here, and you're going to have another 19. So the 20th and the 21st numbers, you're going to take the average of the two of them. So average of 20 and 21. So that's how we would find the median. Alright, so let's actually move on to making some stem and leaf plots and some dot plots. So here we have a particular Virginia high school. The math department consists of 20 teachers and their ages are as follows. So what I want you to do is construct a dot plot for the data and a stem plot for the data. So as you're constructing these, think about which one would probably be a better representation of this data. Pause the video here and make your own. So here I have my dot plot and my stem and leaf plot, and as I was making this dot plot, I was like, this is way too much work for that big of a spread of data for this amount of numbers. The dot plot, yes, it shows that most of our teachers are younger. If we look down here, more of our numbers are right down here. We got some older teachers, not as many. But that was a lot of work that had to be done to show that data, whereas a stem and leaf plot down here, this was a little bit easier of a way to represent this data, and it worked just as well. It gives us the exact same thing where we notice, oh hey, more of our teachers are in their 20s, their 30s, their 40s. We've got less teachers up there in their 50s, 60s, and 70s. When you made your stem and leaf plot, I hope you remember to put your key in. Remember, that's just letting us know how to read that stem and leaf plot. So next we're going to complete a frequency table below, and then we're going to create the histogram. So pause the video here and make your frequency table and your histogram, and then we'll talk about them. So here is my frequency table. I got there 8 people in the first interval, then 3, 4, 3, 1, and 1. And as I made my my histogram, I made sure to show each interval in there. Remember, the bars are all the same, and that you can see that frequency up the left side, up the y-axis. And so now that we have that created, let's answer some questions. So describe the shape. Is it roughly symmetric, roughly skewed left, roughly skewed right, or no discernible shape? Well, if I look at this, it kind of goes like this. And remember, when we're saying if it's not symmetric, there is a discernible shape to it, so it's not either of those. It's either skewed left or skewed right. And remember, whichever one, we look at the tail end, and that's the side that we say. So the tail's over on the right side, so we would say that this is skewed right. Describe the spread of the distribution. Well, it's the data is more heavy on the lower numbers. It's a lot lighter down in the upper numbers. What is